And welcome to Empowered Learning. This particular lesson will be on how do we deal with permutations where the elements that are being considered in a permutation have some repeats in it. So let's get started. So for our definition here, we really just have a formula. And so our formula, which comprises of p factorial divided by p sub 1 factorial times p sub 2 factorial all the way to p sub k factorial, is basically saying this. We want to take out all the repetition in a possible permutation or number of permutations. And so if we had no repetition in any of the elements that we're using, then we would just consider that as p factorial. So let's say we had a 10-letter word and all of the letters in the word, were distinct, meaning that they were different or unique. Then of course there would be no repeat, and so this whole denominator here would just be 1, and so therefore we would just say we have, in this case, 10 factorial different ways that that particular word could be arranged letter-wise. Okay. However, we see that when we start dividing by certain factorials, just like how we see in the combination formula, and I'll go ahead and rewrite that one here. If you've tuned into my previous videos on the introduction of permutations and combinations, you'll remember that I said that this r factorial represents the repetition that is in the combinations that is being taken out because order doesn't matter. Okay, so for here, again, if we have the set with 1, 2 in it and the set with 2, 1 in it, of course, if we're doing the combination of these two are the same thing, so we need to eliminate one. And that's what that r factorial is doing. Similarly, this is what the p sub 1 factorial, the p sub 2 factorial, all the way to the p sub k factorial is doing. Now, to get a little bit more specific, we're going to say what these p sub 1, p sub 2 factorials are. And so noting that p is a total number of elements, that means all distinct ones as well as the repeats. P sub 1 is the total number of times the first element that we're considering repeats. P sub 2 is the total number of times that element 2 repeats. And so when we put that in and do the factorial on it, what we essentially do is get rid of all the repeating type of forms that we have within the permutations. So we're going to see two examples of this using two different words. Both of these words have letters that repeat in it, so we're going to take that into account whenever doing the permutation. So we want to first look at this word Bonneville. Okay, so when we look at this, we want to first count how many actual letters we have, and then from that, what we want to do is figure out how many times each letter repeats, and then we'll just use that in our formula here. So we distinctly have a B, we have an O, we have an N, and of course that repeats 2 times. We have an E, and that repeats 2 times. We have a V, we have an I, and we have an L that repeats 2 times. Okay, so of course the B, the O, the V, and the I only show up once, but the N, E, and L show up 2 times. So if we wanted to know the total number of distinct permutations of this particular word or arrangements of it, what we would do is basically say this. We would say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different letters, okay, in the word, and then we're going to divide that by the number of repeats. So here we have the first letter only repeats once, second letter only repeats once, so we have 1 factorial, and then our N repeats twice, E repeats twice, V and I only repeat once, and then L repeats twice. Okay? And so from there, of course, all of our 1 factorials is just 1, so it's essentially 1, so we can get rid of them. So I'm going to go ahead and do that now. And what we have left here is just 3 2 factorials. And so, of course, 2 factorial is just 2 times 1. So all of these are just going to equal 2. So we have 2 times 2 times 2. And so now we see for our 10 factorial here, we need to break this down. And so if we break it down, we need to break it down to where we at least have 3 even numbers so that we can have some clean reducing to 1 going on. Okay, so I'm going to rewrite this, give myself a little more room. So we got 10 factorial divided by 2 times 2 times 2. And so we're going to break down 10 factorial like this. 10 times 9 times 8 times 7 times 6 times 5 factorial. And all that 2 times 2 times 2. So if we look here, we see that this 2 goes into 10 5 times. This 2 can go into 8 4 times. And this 2 can go into 6 3 times. And so now we just write what's left. 5 times 9 times 4 times 7 times 3 times 5 factorial. Okay? And so, of course, we multiply. That'd be 45, 28 times 3, and 5 factorial. And so once we're done there, we can multiply all that and get a particular number. And so I'll just check to see what that is right quick, and we'll compute it. Okay, so let's go ahead. I'll grab a calculator right quick and do it. So we have 45 times 28 times 3 times 5 factorial. And the number that we get here, and I'll go ahead and erase this now, would be 453,600. So for this 10-letter word, we have that many distinct permutations of it taken into account of the repeats. Okay? So now let's go ahead and look at our second one, which is Mississippi. Okay? So again, we want to count how many total letters we have, and then after that we want to figure out how many distinct ones we have and how many times they repeat. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So according to our formula here, we would say that this is 11 factorial. And then here we need to figure out how many distinct letters we have and how many times they repeat. So Mississippi has an M, has an I, and it repeats 1, 2, 3, 4 times. Has an S, 1, 2, 3, 4 times. And we have a P, shows up 2 times. And so here we see that our M only repeats once, our I repeats 4 times, S repeats 4 times, and P repeats twice. And so now what we'll do is go ahead and, of course, 1 factorial is just 1, so we'll get rid of that. And so from here, we will just break this down as much as we can. Okay? So I'll go ahead and get rid of this now. And so 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. So we got 4 factorial, and 2 factorial is just 2. Okay? So we start off there. We know that these 4 factorials reduce to 1, and of course 2 goes into 10 5 times. Okay? And so now from there, we'll now break down the 4 factorial in the denominator, 4 times 3 times 2 times 1, and write everything else that we have in the numerator. And so here we see that this 3 can go into 9 3 times. We see that this 4 can go into 8 2 times. And we see that this 2 can go into 6 3 times. And so from there, we just say 11 times 5 times 3 times 2 times 7 times 3 times 5. And so that's what remains, and all we need to do is multiply all those numbers together, and then we will get the result. So I'll go ahead and do that now in the calculator, make it fast. Okay, and our result ends up being 34650. So 34,650. So with this particular word, we have 34,650 different ways that we can represent it, with the repetition of the letters being included.